Good morning. I am Fiorella from Universidad Pacífico, and today I will present the study titled a Vulnerability Assessment of Mining Conflicts in Peru using ISAHP. Let's start by highlighting the importance of mining in the Peruvian economy. This activity represents 6.7% of the GDP and 52.5% of exports. However, its economic relevance contrasts with the social conflicts it generates. According to the Peruvian Institute of Economics, 64% of active conflicts in the country are related to mining. And this is why the objective of this study is to evaluate the vulnerability of mining projects to these conflicts from three key dimensions: economic, environmental, and social, applying the ISAHP. Regarding the methodology, ISAHP allows complex problems to be broken down into more manageable hierarchies. And for this analysis, we built separate models, one for economic, other for environmental and social dimensions. We use pairwise comparisons to weigh the criteria and verify the consistency of the model. And the mining projects evaluated are three of the main copper producers in Peru: Antamina, Las Bambas, and Southern. These projects were chosen because they are the primary contributors to copper production in the country and a metal that represents a significant part of Peru exports. In this analysis, we use two variables for each dimension related to mining projects. Starting with the economic dimension, the variables selected were royalties and mining canon, because lower mining canon can increase the likelihood of social conflicts, as when the benefits are not distributed fairly, as in the case with the mining canon, tensions arise in local communities. This happens because people feel that they are not receiving what they deserve. And in the other hand, in the environmental dimension, the variables selected were greenhouse gas emissions and accidents. GHG emissions are a key indicator of the environmental impact of mining. They not only contribute to climate change, but also intensify negative perception of mining operations, generating distrust among nearby communities. About accidents, such as chemicals spills, are critical events that can trigger social tensions, as they reveal perils in environmental management and endanger the population. Regarding the social dimension, the selected variables were employment and education. Education measured through investment in infrastructure and education project. This variable is important, is fundamental basically, because you can see the improved living condition in communities with that. However, when resources are insufficient or results are not visible, this can increase the risk of social conflicts. And regarding employment, when mining generate jobs are few or poorly distributed, this also increases tensions. However, when mining projects have a positive impact on local employment, they foster acceptance of mining activities and reduce the likelihood of conflicts. This will be a general view of 3AHP in economic, environmental, and social. By applying the ISAHP method to compare the variables in each ISAHP, we identify which variable have the greatest capacity to generate social conflicts. In the economic dimension, that is right here, royalties were more important than mining canon, as a low mining canon can increase the tension. And in the environmental dimension, accidents were considered more relevant than GHG emissions, as they are usually immediate triggers for conflicts. And in the social dimension, The education stood out over employment, as the lack of investment in education can reinforce the sense of abandonment and generate more tensions. In the alternative matrices, we evaluate the vulnerability of each mining project to social conflicts based on each ISAHP. In the economic ISAHP, Southern has the highest score in royalties, indicating greater vulnerability to conflicts over resource distribution. Las Bambas is more vulnerable regarding the mining canon with a higher score. About the environmental dimension, Southern is more vulnerable to conflicts due to accidents, and while Antamina has the greatest vulnerability because of its GHG emissions. And finally, with the social ISAHP, Las Bambas shows a higher vulnerability due to its higher score in education. Also, Southern has a positive impact on employment, which could reduce tensions. Now let's look at the results of our analysis represented in these three maps, which show the vulnerability of each mining project to social conflicts in the economic, environmental, and social ISAHP. In the economic dimension, Southern is the most vulnerable, followed by Antamina, while Las Bambas has the lowest vulnerability in this area. In the environmental dimension, Southern presents the highest vulnerability too, particularly due to accidents, while Las Bambas and Antamina have a lower vulnerability in this aspect. And finally, in the social dimension, Las Bambas shows the highest vulnerability due to the lack of investment in education. Also, Southern has an impact on employment, which could help to reduce some tensions. These maps clearly shows the distribution of vulnerability for each project in the analyzed dimensions. And the integrate analysis reveals that Southern is the most the most vulnerable company overall, while Las Bambas faces specific social challenges. In conclusion, this analysis used ISAHP to evaluate the vulnerability to social conflicts in Peruvian mining sector. We got that the Southern is the most vulnerable project, and Las Bambas needs to invest more in education to reduce social tensions. And overall, the analysis highlights priority areas for companies to improve their social, environmental, and economic performance, fostering more sustainable policies. Finally, for future projects, there are a few areas to improve. The model used in this analysis, being independent for each dimension, limits the availability to analyze interaction between them, which could provide a more integrated view of vulnerabilities in general. Also, we focus on only 3 mines, which restricts the ability to generalize the results to a wider range of mining projects in the country. And another important aspect is the lack of direct feedback from local communities, which could enrich the analysis and provide a more complete perspective of tension and needs on the ground. To move forward, it would be advisable to develop a unified model that allows for the analysis on interdependencies between the different dimensions and expand the study to include more mining projects. Thank you for your attention. I can hear you.
Very, very good. Thank you. May I ask a question, Alvaro?
No, that is a good word that reflects a real problem in Peru. no? And I think that if you consider it another criteria and for the environment dimensional.
Yes, sorry, I didn't notice that my camera was off.
Okay, no
Um, about the question, yes, I think that I would add like two variables related to environmental. One is about the NDVI, that is the normalized difference vegetation index, and the other one would be the NDWI, that is the normalized different weather index. This because the NDVI is useful for assessing vegetation health and coverage, which can influence conflicts related to biodiversity loss or ecosystem changes caused by mining activities, and the NDWI because this evaluates the water availability and quality in areas near to mining projects, which is crucial because mining can affect water resources, one of the main sources of social tensions.
Thank you, Fiorella. Another question
Yes.
in this room? Okay, thank you, Enrique.
Yeah. Well, there have been four composite indicators projects here. In the case of the vulnerability cases, there are three aspects that are very important when you're presenting. I guess you're using this for your doctoral dissertation. Number one is the criteria selected need to make sense. I mean, you need to show that they were those criteria, what affects anemia or what affects mining, social unrest, that the criteria that you have selected are those that the experts say they should be used, and that they actually affect the anemia, the social unrest, the earthquake vulnerability, etc. Okay? So it's very important that you can justify why these criteria are not others. Second, it must be possible to feed to measure those criteria. Like in the case of the anemia, the indicators, the numbers, the data are obtained from the National Institute of Statistics, etc. Because if you have criteria that is very hard to measure accurately, then the model is not practical. So you need to be able to get the data in an easy way, because I mean, you cannot be running a whole project each time you want to run the vulnerability. You need to run surveys of that. So the data, how you're gonna get the data in an effective and accurate way. Third, the predictive capacity of the model. One of the models says that predicts the vulnerability to anemia based on those four factors. In order to believe that, I would probably ask to check those four factors, the values they had for the past 10 years, and what the extent of anemia has been for the past 10 years. If your model assesses vulnerability correctly, I should be a correlation between your indicators that whenever you predict that there will be more anemia or there is more vulnerability, there is actually more anemia, right? And the same for vulnerability to earthquakes, and the same for, I'm sorry, I missed this last model. You must, in an ideal world, you must run an analysis applying your model to the past and to see that it's actually been predicting correctly what it's supposed to predict. And the cherry on the cake, this is more recently, let's say, more recent research related to composite indicators in ISAHP, is that you must calculate a threshold. At least the government must be able to decide on a threshold to say above this value, it's unacceptable. If you have sorry that I refer to anemia all the time because it's much easier to use as an example. Let's say there is anemia in all the departments in Peru, just that it's different. The question is, your indicators, what is the threshold at which you say the action should be taken? Okay? What is minimum dangerous? For a long time, the developers of composite indicators have been avoiding to do that. You know, they say, well, this is the one that has, according to the highest indicator of vulnerability, the lowest indicator, and so let's attack the one that has the highest indicator. But you should mind there will always be vulnerability. There will always be anemia. So what is your threshold, which is the minimum before you decide to take action? Okay, it is like when you go to the casino, there is a vulnerability you will lose. So what's going to be your threshold of loss? At what value you will say, I don't play this game anymore? I will facilitate your advice of some additional literature on this topic, but this is very good. I think you are definitely on the right track, and these models are extremely useful. I think that's also very important. That's it.
Thank you, Enrique. Thank you for your advantage and recommendations. All works I solved with the authors. And thank you